Hello and welcome to another tutorial. This is Oxford Complete Mathematics Unit 7 and this is 7.1, which is about linear graphs. Then this lesson is the extension of the previous lesson. Then this is question 17, page 238. Let's get started. Firstly, we have something like a word problem. So let's get started. The equation connecting the annual distance traveled m kilometers of a certain car and the annual running cost c is equal to m over 20 plus 200. Then draw the graph for 0, m, 10,000. So the interval of m is from 0 to 10,000 using the scale of 1 centimeter for 1,000 kilometer, and for the cost 2 centimeter for $100 for the cost. Now this is the first quadrant of xy axis. Because these are about distance and cost, it cannot be negative at all. That's why I just draw here the positive quadrant of xy axis, and this vertical line, which is y-axis, according to this question, it's not y anymore. It must be c, cost, because c is equal to something containing m. As we used to work on y is equal to something containing x, then here c is equal to m over 20 plus 200. It means this vertical line is the c, and this horizontal axis is not x-axis anymore. It must be m, because m is inside the equation. Okay, now the scale should be 1 centimeter for 1,000 kilometers. So it means the first centimeter represents the first 1,000 kilometer. 2,000, 3, 4, 5, 6, 7, 8, 9, 10. So 10 centimeters stands for 10,000 kilometers, and for the cost 2 centimeters means 2 squares represent $100. Then here is the first square. Second square is $100, then $200, 3, 4, $500. We might need more. It's fine, we can extend the line. Then done. The equation is like this. C is equal to m, which is the distance, divided by 20. Then this result plus 200. To draw the graph of this model, to draw the graph of this equation, we can follow the table the safest way. So here are the m values. We're going to pick some values for m randomly from 0 to 10,000. And then we're going to work out the c for each value of m. Then since the m should be between 0 to 10,000, it's fine to pick 0 first. 0, we can say 4,000 and 10,000. We picked the values for m. Let's work out the value of c for each of these m's. If we put 0 in place of m, we will have something like this. 0 divided by 20, then the result plus 200. 0 divided 20 is 0 plus 200, it is 200. And 4,000 over 20 plus 200. 4,000 divided by 20, then 1 0 will cancel 1 0. 400 divided by 2 is equal to 200. So this part will be equal to 200. 200 plus 200 is 400. And for the 10,000, we will have 10,000 over 20 plus 200. 10,000 over 20 plus 200. 1 0 will be cancelled with this one because it's just one independent fraction. Then 1000 divided by 2 is equal to 500. It means this fraction part is equal to 500 plus 200. We got 700. Okay. Our vertical axis, which stands for C, goes up to 500 because the first 2 centimeters, this is $100, then 200, 300, 400, 500. To get 700, we need to go 4 more squares. So let's just simply extend the line we have up to here. Perfect. Here, 2 more centimeters is 600. 2 more centimeters is 700. It's fine. Even when you are working out, if you see your x-axis or y-axis is shorter than what you expect, you can just extend it with your ruler. It's fine, although it doesn't affect the graph. Okay, now the first point we have is 0, 200. 0 in M is right here, 200 is there. So this is the first point, 0, 200. The second point is 4,400. Where is 4,000? Each marker represents 1,000, then 1,000, 2,000, 3,000, 4,000 is going to 400. It's right here. And 10,000 with 700. 10,000 and 700. Here is it. Now let's join them with a straight line. Then we will be able to answer part A and part B. This is the graph. The cost when the annual distance traveled is 7,200 kilometers. Now, let's see using a, let's use purple. Red is good here. Where is 7,200 on this line? 7,200, 1, 2, 3, 4, 5, 6, 7. This is 7,000. 7,500 is halfway. Less than halfway is 7,200. It's kind of estimation. Now let's see, where does 7,200 on M crosses the graph? It's crossing the graph between it's crossing the graph between, this is where, so this is where the 7,200 kilometer is crossing the graph. Then this number, can we estimate this number? Yes, between 500 and 600, halfway is 550. Halfway is 550. Halfway is 550. Then the next halfway here is 550. Halfway between 500 and 600 is 550. Then it looks like the halfway between 550 and 600. So it could be $575. The cost of 7,200 kilometers is $575. Part B, the annual mileage corresponding to a cost of $320. Then where is $320? Where is it? We need something like this again. So you are going to use ruler to see where does 300, this point halfway between 300 and 400 is 350. So 320 is nearly halfway between 320, even a little bit less than half, 350 and 300. Then let's see where does this cost, which is $320, crosses the line. It crosses the line right here. So it is opposite this point on M. This point on M is 2,500. Then $320 is opposite 2,500 miles. This is 1,000, 1,000, 2,000, 2,500. The answer of part B is 2,500 miles. Done? Now let's move on to question 18. Question 18, it sounds like the previous question. Question 18, the equation relating the cooking time T, so T works like Y because T is equal to something containing M. T means time in hours and the mass M in kilograms. And this is the relation. T is equal to 3m plus 1 over 4. Draw the graph for m between 0 to 5. From the graph, find the mass of a cake requiring time of 2.8 hours. The cooking time for a cake with a mass of 4.1 kilogram. Then again, we have to start by drawing the graph. Firstly, the equation is like this. T is equal to 3m plus 1 all over 4. The values of m must be between 0 to 5. And the first thing is the table. M is inside the equation. M is here. It works like x and t is there. Now, the values of m must be between 0 and 5. So I'm going to pick 1. It's fine to start at 0. I'm going to pick 1, 3, and 5. Let's work out the value for t. So even 0, it's fine. You are free, whatsoever you pick here. Then let's work out the value of t for each of these numbers separately. The first one, when m is equal to 1, then we will have something like this. 3 times 1 plus 1 over 4. 3 times 1 is equal to 3 plus 1 is 4. 4 over 4 is equal to 1. So when m is equal to 1, t is also equal to 1. Now for 0, we will have 3 times 0 plus 1. 3 times 0 is 0 plus 1 is just 1. Divide 4 is 1 over 4 or 0.25. Both acceptable. 1 over 4. Now if we put 3 in place of x, we will have 3 times 3, which is 9, plus 1 is 10. 10 divided by 4 is 2.5. It's fine to keep your answer as fraction or decimal. It's your decision. And finally, if m be equal to 5, 3 times 5 is 15, plus 1, 16. Divide by 4 is 4. Now if we look at the table, we see the highest value of m is 5 and the highest value of t is 4. So 5 by 5 xy axis will be enough. 1 2 3 4 5. 1 2 3 4 5. This is enough. All values are positive, and since it's about mass and time, they are always positive, so it's fine to not draw the other parts of the xy axis. It's fine to draw only the first quadrant of the xy axis. But in this case here, in this question, we don't have x and y, we have t. T is equal to something containing m. It means the horizontal line is m and the vertical line is t. Now let's plot these points. The first point is 1 1. 1 1 is right here. The second point is 0 1 over 4. 0 is here. 1 over 4 is here. 3 2.5. 3 2.5 is here. 1 2 3 and 2.5. 1 2 and 0.5 is halfway. And finally 5 4. When m is equal to 5, t is equal to 4. Now let's join these points with a straight line. Then this is the graph. Now the mass, part A, the mass of a cake requiring a cooking time of 2.8 hours. 2.8 hours. 2.8 is too close to 3, and it's about t. It's time in hours means t. Then we're gonna find 2.8 on this vertical line. To find 2.8 hours, it's about time, then we have to find 2.8 on the vertical line. Then 2.8 is around here, it's too close to 3. And then 2.8, this line is crossing the graph here. Then to extend this line, extend from this point, so it's crossing the m-axis in somewhere less than 3.5. It's 1 2 3 and 3, it's less than 3.5. let's simply say it's 3.45. These 3.45, 3.5, they are all acceptable because the graph is here. According to the graph, these numbers are too close to each other. Part B, the cooking time for a cake with a mass of 4.1 kilograms. Then 4.1, let's erase this. 1 2 3 4. 4.1 is too close to 4. It crosses the graph nearly here. So 4.1 is here on M axis, and on T axis it's too close to 3. 1 2 3, and this is less than 3.5, so it's nearly 3. We can say it's 3.3. This is the answer of part B. According to the graph, we can estimate these answers. To check your answer, we can use the equation. How? We're going to use the equation. In part A, we found the mass. It means this 3.45 is the mass. When it's the mass, it means we can substitute this 3.45 in place of m. We need to get something too close to 2.8. Let's see. 3 times 3.45. 3 times 3.45. Then plus 1 all over 4. It's equal to 2.83, so it's nearly 2.8. So it means we got part A correct. In part B, the answer is 3.3. This 3.3 is the T. Now let's substitute 4.1. 4.1 is the M. 4.1 is the mass for part B. Then we have to put 4.1 in place of m. then we will have 3 times 4.1, then the result plus 1 all over 4. Look, it's 3.32. It means nearly it's 3.3. It's correct. So we checked the answers. They are all fine. And we estimated them on the graph. And we checked them using the equation in calculator. And we got everything correct. Question 18 is done. Question 19. This is your task for this lesson. Question 20. The value of a car V is related to the number of kilometers n which it has traveled by the equation V is equal to 4,500 minus n over 20. As usual, to draw the graph for this equation, we start by making a table. V is equal to 4,500 minus n over 20, and the value of n is from 0 to 90,000. Then from the graph you can answer part A and B. Let's do the table first. N is inside the equation. N must be here. It works just like X and V there. The values of N must be between 0 and 90,000. It's better to pick something that are divisible by 20. That makes your calculation easier if you are not using calculator. Even if you are using calculator, it gives you some whole numbers that are easier to be plotted on XY axis. Then the first value of n is 0. Then we can pick 5,000, 10,000. Can we pick more? Of course we can. And let's pick 90,000, which is the upper bound of this domain of n. Now, if we put 0 in place of n, we will have 0 over 20, which is just 0. 4,500 minus 0 is just 4,500. The first one done. For 0, it's 4,500. Now for 5,000. And we have something like this. 4,500 minus 5,000 over 20. It's equal to 4,250. When we put 5,000 in place of n, we get 4,250. Now for the 10,000, 10,000 divided by 20. So again, we use the same equation, but this time we have 10,000. 4,500 minus 10,000 over 20 is equal to 4,000. And 90,000 now we have 4,500 minus 90,000 over 20 is equal to 0. Okay, we got 4 points. Now let's make a proper XY axis to be able to feed all of these numbers. The maximum value for V is 4,500 and the maximum value for N is 90,000. N will be the horizontal axis and V will be the vertical axis. All the numbers are positive. It's fine to just have an XY axis like this. Let's draw a big one. 1, 2, 3, 4, 5, 6, 7, 8. 9. Okay. The V axis, the vertical one, is going by 500. It's acceptable. And the other one is going by 10,000. So 10, 20, 30, 40, 50, 90,000. Okay, it's fine to label them. This is N, the horizontal, and this is V, the vertical. The V is going by 500. First one is 0 is here, then 500, 1000, 1500, 2000, 2500, 3000, 3500, 4000, and finally 4500. The n-axis is going by 10,000s. So each line here is representing 10,000, 10, 20, 30, 40, 50, 60, 70, 80, 90. We can write it like this. N, which is the mileage or number of kilometers in thousands. N in thousands. Then this is 10,000, 20,000, 30, 40, 50, 60, 70, 80, 90,000. Now to plot these, the first one is 0, 4,500. Then 5,000, 4,250. 5,000 is halfway between 0 and 10. 4,250 is halfway between 4,000 and 4,500. These 2 points are looking too close to each other. Then 10,000 is with 4,000. They are too close to each other, but they form a very straight line. 90 and 0. Now join them with a straight line. Okay, we got the graph. Now let's use this graph to answer part A. Part A, the value of a car which has traveled 3,700 kilometers. 3,700 on the graph, 3,700 is less than half, so it's nearly, because it's more than 4,250, then the answer of part A is nearly 4,000. Part A, the answer is nearly 4,300 or more, like 4,350, 4,360. All the numbers are possible. Part B, when the value of a car is 3,200. 3,200, so the value is close to 30,000. The number of kilometers is close to 30,000, but it doesn't reach 30, so it means we can say it's nearly 28,000 kilometers. This one is the value, dollars, and this one is kilometers. Now let's use the equation to check the answer of part A and B to see how close we are to the correct answer. So this equation, 4,500 minus n over 20. For part B, the n is 28. The n is 28,000. Let's see, will we get something close to the cost which is given in the question? So yes, it's close, it's acceptable. 3, if we put 28,000, it's 3,100 on the graph. As estimation, it's fine, but when you check your answer, you see 28,000 is 3,100. You can just increase the 28,000 and see the result. If we put 29,000 as estimation, 29 is also acceptable. We will get less, then it must be less than 28,000. Let's say 27,000. It's getting $3,150. It's even closer. Let's give a try to 26,000. Then it's perfect. 28,000 is a good estimation, but once we calculate it, we got that it's 26,000. Then part B, we just replace the 28,000 by 26,000 because it's perfectly correct. Part A, this is the cost, 4,300, but number of kilometers, n, is given in the question, 3,700. So now let's just put 3,700 in place of number of kilometers, which is n. Let's see what we get. 3,700. We got 4,315. So part A, it was a very good estimation. We don't have to change it. It's $4,300. It's too close. So done. That's it. I hope you find it easy. Comment below whatever question you have. Thank you for watching.